If we do this one step at a time, in the numerator, how many 5s do we have? 7 of them. So we could write that as 5 to the 7. Okay? Again, it's probably easier just to think how many 5s you have rather than just going straight to your rule. The rule is when you multiply, you can add the exponents. But it's just as easy to think about what does an exponent mean? It's repeated multiplication. And so I would have 7 5s on the top. But here, we have the quotient rule and we have a negative, so we do need to use our rules. Oh, I'll change mine to match. Yours is a 4 on the bottom? Does that match better? Okay. I wonder why I changed that. Anyways. So now, if they are positive numbers, it's easy to visualize and you can realize I need to subtract. But since it's a negative number, we have to use the rule and we have to say I need to subtract 7 minus a negative 4. Subtracting a negative is the same as adding 7 plus 4 is 11. So we get 5 to the 11. Simplify, okay? So here, simplify means that we want to write things, if we can, as a single power, and then evaluate. How many negative 6s are left? Careful. We have 5 of them on the top, 3 of them on the bottom. They're going to cancel out. Right? When you're dividing, things cancel out because same number divided by itself.
Oh, no, I'm not answering the question. I have one.
You have a question. Yes.
Are we going to be doing independent today?
Well, there might be a little bit of time, but since the bus ridership, there might not be a lot. Okay? Negative 6 to the 5, negative 6 to the 3. If you imagine that with your what the definition means, you'd have 5 negative 6s on the top, 3 on the bottom. They'd cancel out. How many would be left? 2 of them. And this you can evaluate without a calculator. What is negative 6 squared? Careful. Negative, the squared means repeated multiplication. So if you wrote it out, it would mean negative 6 times negative 6. 36. Positive or negative? Positive, right? Because a negative times a negative would be positive. So this becomes 36. And we can do this without our calculator. But if you tried to do this at the beginning without your calculator, 6 times 6 times 6 times 6 times 6 is way too big to figure out in your head. So then you would have to use a calculator. But if we simplify first, we can do it without our calculator. Okay, second one in green. Do we have any powers we can simplify? Yes. Here in the second part, how many 4s would be left? We're dividing. Think about them canceling out. How many 4s are left when you have 4 cubed divided by 4 squared? Make sense? 1. And would it be on the top or would it be on the bottom? It would be on the top. So that's just like 4. And now, mental math. What is 2 cubed? What is 2 times 2 times 2? Careful, try it again. 2 times 2 is? Times 2 again?
16.
4 times 2 is 16?
Okay.
All right. It's 8. And then you'd have 8 plus 4. maybe 4 or 5. Not too many. Part C. We have dividing here with the same base. How many 10s would be left? 4 on the top, 2 on the bottom, they'd cancel out. You'd be left with 2. Mental math, what's 10 squared? 100. Mental math, what is 3 times 3 times 3 times 3? Okay, and I'm going to do this to make it easier for you. 81. Right, because why did I circle the 2 3s? Because 3 times 3 is 9. So by circling those 2 3s, you realize, hey, this is just the same as 9 times 9, which is a little bit easier mental math than going 3 times 3, which is 9, times 3 again, which is 27, times 3 again, which is 81. So you have 100 minus 81. Someone buys something for $81. They give you $100. How much change do they get? $19. Okay. Our next exponent law is the exponent of 0. What happens when you have an exponent of 0? Well, we're going to look at these, and we're going to see if you can figure out a pattern to figure out what 2 to the 0 is and what 2 to the minus 1 is, because we haven't done those yet. But 2 cubed, we just said, was 8. What's 2 squared? 4. 2 to the 1 means you just have 1, 2. It's equal to 2. Our numbers are going down. Can you see a pattern? Going 8 to 4 to 2. If you went down again, what would you get to? So what's your pattern? How do I go from here to here? Divide by 2. Does that pattern work from here to here? So what is this answer going to be? It's 1. 2 to the 0 is 1. Because if you divided by 2 again, you would get 1. What is 2 to the minus 1? No. No. What's the pattern? What should I do again? I should divide by 2 again. What if you have 1 and you divide by 2? What do you get? 1 divided by 2? That's be like, you have 1 chocolate bar, you have 2 friends. How much do they each get? None. No. They get 0.5 or 1/2. So this will be 0.5 or, and it's more often that we'll write that one as a fraction, 1/2. Okay? Let's look at powers of 3. 3 cubed is 27. 3 times 3, 9. 3 to the 1 is 3. What's the pattern here? How do I go from here to here and here to here using the same pattern? And then we have to use that pattern again to go from here to here. Thank you. Dividing by 3. So what's 3 to the 0? 1. And if you divide it by 3 again, 3 to the minus 1, it's 0.33 repeated, or more common, we'll write it as 1/3. Okay, now I'm not going to give you the pattern. I'm just going to ask you, what do you think 4 to the 0 is going to be? What do you think 5 to the 0 is going to be? What do you think 11,392,481 to the 0 is going to be? Okay. Bonus question for Friday. What number did I write down? Could you remember it? No, I'm not going to do that as a bonus question. Okay, that is your zero exponent rule. Okay? But what ends up happening to a lot of students from grade 9 to 12 is they remember their zero exponent rule, that things are equal to 1. Sometimes they memorize it and forget it. But what you need to think about is, could you make this pattern again? Because if you can make the pattern again, you will not forget the zero exponent law. If you can't make the pattern, chances are you'll forget from now until your end, maybe even Friday, or you'll forget before your exam in January. So if you can remember the pattern, it's going to help you. Okay? This is equal to 1. This is equal to 1 for a number of reasons. First of all, if you think about it, it's 2 cubed is 8. 2 cubed is 8. What's 8 divided by 8? 1. So that's a very good reason why this is equal to 1. Some people say another way I think of it is I have 2 times 2 times 2 divided by 2 times 2 times 2. 2, 2, 2, 2, 2. They all cancel out. I mean, 2 divided by 2 is equal to 1. So when everything cancels out, you're left with 1. Or you could do the exponent law. And the exponent law says when you divide, you subtract. And if I subtract, I get 2 to the 0. And 2 to the 0 is equal to 1. So the important thing in mathematics is things have to work out the same every single time, no matter which method you use. Right? It wouldn't be in good mathematics if you're like, oh, in one method I get one number, in another method I get another number. That's not good mathematics. So whether you use your exponent law and get 2 to the 0, it's equal to 1, or you evaluate it and get 8 divided by 8, it's equal to 1. So your exponent of 0 law says anything to the 0 is equal to the 1 as long as you don't use 0. This one, if you type it into your calculator, doesn't exist. It gives you an error. But anything else to the 0 is equal to 1. It doesn't matter what the base is, so you have to add the word the in there. Unless you just like to read it that way, it doesn't matter what base is. Any base to the power of 0 is equal to 1. Okay. Whew. The bus ridership time took up a bunch of our time. Okay? Be careful here. Not all the answers are 1. Some of them are not. But I'd like you to evaluate all of these. Five to the 0 is 1. 325 to the 0 is 1. Negative 2 to the 0 is negative 1. Ooh, this is the first tricky one. Why? Because order of operations here would say, first you do 2 to the 0. 2 to the 0 is 1, but there's a negative out in front. That negative gets multiplied by that 1, and then you get negative 1. What about negative 2 to the 0? This one is positive 1 because the negative is inside. A to the 0, 1. 2 to the 0 plus 3 to the 0, 2, because this would be 1, and this would be 1. And the difficult math here is the 1 plus 1. And gee, the answer is 4 times 3 to the 0. It is 4. If you did the wrong order of operations, if you did 4 times 3 first, which is 12, and then did 12 to the 0, you would get 1. But order of operations, BEDMAS, says I should do the exponent before I multiply. So 3 to the 0 is 1. And then 4 times 1 is 4. 2 plus 3 minus 5 plus 4 is, to the power of 0, is 1. Because you do the brackets first. That whole thing is equal to 4. And then you have 4 to the 0, which is equal to 1. And this one, 2 plus 3 minus 4 plus 4, 2 plus 3 minus 5 plus 4, all to the 0 times 3. The answer is going to be 3, because all of this to the 0 is going to be 1, but then you still have that 3 out in front. 3 times 1 is 3. Okay. This is what we're going to do tomorrow.